Today we are going to see the double shear test. So that's a next experiment in the lab. So here the shear is given to the specimen. The specimen used is a mild steel rod of diameter some 10 to 12 millimeters. Then we will be applying the shear load on this specimen and we will be finding the shear resistance of this material. Okay, so this is a specimen is made of mild steel. So we are going to find the shear resistance of mild steel. So first take the specimen, measure the diameter, then fix it in the shear testing attachment. So here you have the shear testing attachment. So it consists of a block, and this part is the specimen is going to be inserted over here, and then this part will be placed in this block such that the specimen is equally placed to both the sides. So the specimen will be placed inside this, and then later this part will be placed inside the block. So the specimen will ultimately be like this, with this part, the specimen within this part. Then, so this is the attachment for doing the shear test. So what we are doing here, so you have the specimen which is placed inside the attachment. Then we are going to apply the shear load and find the shear resistance of the material which is mild steel here. So how to do the test? Here also we are going to apply a compressive load. So since we are applying a compressive load, the attachment with the specimen kept inside will be placed over here, and then the compressive load will be applied by moving this head, and then we will be applying the load. Break out. Now to do the double shear test, first we have to calculate the range in which UTM has to work. So the yield stress for mild steel is 250 Newton per millimeter square. So based on that, you calculate the load that is going to act on the mild steel specimen. So yield stress is 250. Then allowable shear stress is 0.45 times the yield stress. So based on that, you calculate the allowable shear stress. Then you calculate the approximate load that is coming. The load coming will be equal to the stress will be equal to force by area. So the load that is coming, or the force to be applied, that is equal to stress into area. So based on that, you calculate the load that is coming on the mild steel rod. So also please see that here the load is applied over here. So the middle head is moved downwards, and it is just touching this block. It is kept in that position by electrically moving the middle head. It is placed just in touch with the attachment, and then you can see that the specimen is placed over here, and this attachment on which load is applied is actually carrying this mild steel rod at the center. So as load is applied here, what happens is that there will be shear occurring at two planes. രണ്ട് പ്ലെയിനിൽ ഷിയർ ഉണ്ടാകുന്നുണ്ട്. അതായത് ഈ അറ്റാച്ച്മെൻറ്റിൻ്റെ ഇപ്പുറത്തെ സൈഡിലും അപ്പുറത്തെ സൈഡിലും രണ്ട് പ്ലെയിനിൽ ഷിയർ ഉണ്ടാകുന്നുണ്ട്. സോ ദ ഷിയറിംഗ് ഏരിയ യു ഹാവ് ടു ടേക്ക് ട്വൈസ്, and that's why it is called double shear test. So shear is occurring across two planes. So while calculating the load, the stress have to be multiplied with 2 times area. So based on that, you calculate the load at which the shear will occur. Then based on that load, I think the load will be coming around 70, 80. So based on that you determine a particular range for UTM. So since the load is coming to be 80, I select the net highest range, that is 0 to 100. 0 to 100 kilonewton is the range in which UTM is going to work for doing this test. So you know the various ranges of UTM, 0 to 40, 0 to 100, 0 to 200, 0 to 400, etc. So for this test, the ultimate load, the load at which fracture occurs, is calculated to be around 80. So we determine the range of 0 to 100 and then do the test. Now to do the test, so range is selected by the range selecting knob as 0 to 100. Now to do the test, we have to operate the machine hydraulically. So we switch on this valve should be closed so that oil doesn't flow back. So now I am going to open this valve, which means load will be applied. That means this middle crosshead is going to come down, or the load is going to be applied onto this attachment. So thereby a compressive load is applied, and the specimen which is placed inside the apparatus will be subjected to shear across two planes. So we are doing the double shear test. And here what you have to find is the ultimate shear stress, the shear stress at which the specimen will break. So from this dial you will get the load at which the specimen breaks, and from that you can calculate the ultimate shear stress of the specimen. Now I am applying the load by opening this valve. Just note one reading which will be given by this red dial.